Hello and welcome to PA Academy. So this is the part 7 of the video series under Polynomial. So we've looked at six other parts. There are 6 other parts to this video, which you'll find the link in the description of this video. So in this video, we are going to be looking at the factor and remainder theorem under Polynomial. So in explaining factor and remainder theorem, I'm going to be using one of the examples that we use in when we are looking at division of polynomial, where we had 3x squared minus 2x plus 4, so divided by x minus 2. So quickly, let's just quickly solve this so that I'll just go over it, because this is one of the examples we solved in the previous part of this video. So right here we are going to be having x minus 2, and we are going to be having 3x squared minus 2x plus 4. So here will be 3. So 3x squared divided by x, and that will be 3x. So 3x multiplied by x, that will be 3x squared. Then 3x multiplied by 2, that will be minus 6x. So subtract, this will cancel out. So minus 2x minus 6, that will give us 4x plus 4. So 4x divided by 4, that will give us 4. So plus 4. Plus 4 multiplied by x, that's 4x. Then 4 multiplied by minus 2, that's minus 8. So that will give us plus 4 minus 8, that's 12. Now this is the long division method of dividing a polynomial. Now it's important to know that. Now let's know some things. Now this 12 that we are having here is called the remainder. You also call it the R of x. Why this one, the one at the top, is called the quotient. The quotient, you also call it the Q of x. Now this x minus 2, okay, so the x minus 2 that we are having here, that is dividing 3x squared minus 2x plus 4, so we call that one the divisor. Why this 3x squared minus 2x plus 4, the one we are having here, we call this the dividend. So it's important to know these 4 terms. Now when we are talking about the factor and the remainder theorem, you can see that for us to get the remainder here, we had to go through this long division method to get the remainder as 12. But now instead of going through this long method of getting the remainder as 12, so we can as well pick the x minus 2, which is the divisor, and equate it to 2. This is what I'm saying. So the divisor, which is x minus 2, once we equate it into 2, so that will be x minus 2, we equate it to 0, is equals to 0. So by the time we have x minus 2 equals to 0, then if we make x the subject formula, we're going to be having our x is equals to 2. Now that we have gotten our x to be 2, now we are going to put the value of x, which is 2, into the dividend, dividend. This is d. So you are going to put the value of x into 3x squared minus 2x plus 4. So let's do that. So if you're having 3x squared minus 2x plus 4, so now let's substitute, let's put 2 in place of x. So you're going to be having 3 into brackets 2 squared minus 2 into brackets 2 plus 4. So that will be 3 times, so 2 raised to the power 2, that's 4. 4 minus 2 times 2, 4, plus 4. So by the time we equate this, 4 times 3 will give us 12. So minus 4 plus 4 will give us 0, and we'll be left with what? With 0. We'll be left, minus 4 plus 4 will give us 0, and we'll be left with just this 12. Now you can see that following this method, we can see that we have been able to get our remainder, which is this, instead of using the long division method. But using this method has given us the remainder. So that is what the remainder theorem is all about. So by the time you equate the divisor to 0, and then you make by the time you make the divisor, you equate it to 0, and then you get the value of x. So you substitute that value of x, so in this example it was 2, into the dividend. With that, you'll be able to get the remainder. So now let's look at the factor theorem. So the factor theorem is almost similar to the remainder theorem. The difference is this. Now when we are looking at the remainder theorem, by the time we equate, we pick the divisor and then we equate it into 0, and then we substitute that value into the dividend, we are getting a remainder. But right now, what if we do it and we are getting our remainder to be 0? That makes the divisor a factor. Let's look at this example now. So if you should divide x raised to power 3 minus 1 by x minus 1. So like what I explained, we picked it. This is, don't forget. So with this now, this one is called the divisor, and why this is called the dividend. So this is the dividend, this is the divisor. So like what I explained earlier, what we are now going to do is we are going to pick the x minus 1 and we are going to equate it to 0. So by the time we make x the subject of the formula, you're going to be having x is equals to 1. So that means if we had them plus 1 to both sides, we are going to be having our x equals to 1. So what we are going to do now is we are going to substitute the value of x into the dividend. So now we are having x cubed minus 1. So by the time we put the value of x, which is 1, into here, so we are going to be having 1 raised to power 3 minus 1. So that will give us 1 minus 1, and which is equals to what? 0. So now you can see that 1 minus 1 is giving us 0. So in this example now, you can see that it is not giving us any value. 0 is our remainder. So with that now, if 0 is the remainder, that makes this divisor x minus 1 is now a factor of x, is a factor of s cubed minus 1. That's because it's a factor, because by the time we equate it to 0 and substitute the value of the x into this dividend, is going to give us a 0. So that makes it what? A factor. So x minus 1 is a factor of s cubed minus 1. So if it is not giving us 0 and is giving us a remainder, then it might not really be what? A factor. So guys, that is it for this video, and with that we've come to the end of the video series under polynomial. So if you have any question whatsoever under the video so far, please leave them in the comment section below. If you are new to PA Academy or you are yet to subscribe to PA Academy, kindly click on the subscribe button. If you find these videos helpful, please click on the like button, and also make sure you click on the notification bell button after you subscribe to PA Academy. And with that, I'll see you all in another video series. Thank you.